In the last videos I looked at how what I call the linear Ferrite Balun performed and measured its performance from a very low frequency to as high as I could go. In this video I'm looking at the deficiencies that I identified in that performance check. One of them was that the phase wasn't quite 180 degrees, it was a couple of degrees out. And the other was that the amplitude difference between the X and Y was about 5%. So in this video I'm going to explore whether those errors can be removed. When I was developing the balun, I went to quite a bit of trouble to ensure that the internal diameter of the ferrite cores that I used closely matched the external diameter of the coax to minimize the gap between the coax exterior and the ferrite interior. I decided to test the hypothesis of whether the differences between the two channels were due to leakage flux between the coax and the ferrite material. So I had two options. I could have changed the internal diameter of the ferrites and got a whole new set of ferrites, or I could change the diameter of the coax, and that's the option that I chose. I found there was no difference between the two different diameters of coax. It didn't matter whether I had a skinny coax or a fat coax, the response of the linear Ferrite Balun was the same. I therefore concluded that the 5% difference in amplitude between the channels and the small phase difference was a direct result of the properties of the ferrite and not of the physical construction of the balun. This was a bit of a surprise because typically the physical dimensions of an RF component define its response and performance, but in this case it didn't. It does make sense that the response is the same regardless of the diameter of the coax, because the coax is invisible to magnetic fields, and it doesn't matter whether the coax is fat or skinny, the magnetic field that the ferrite cores are exposed to is going to be the same.